All right, we're going to talk about systems of equations, and there's a couple different ways to solve this. And so the first way we're going to do it is by graphing. And by graphing, when they cross right here, this is the solution. And it's always an ordered pair. It's the x and the y. So if I look at example number 1, both lines are in standard form. And by standard form, this is what I mean. I mean, this is written in y equals mx plus b form, where m is the slope. And the slope is the rise over run. And the b is the y-intercept. So if both are positive, you move up and to the right, correct? If both are positive, you move up and to the right. If it's negative, so if I have like a negative over a positive, you move down and to the right. But if it's negative on bottom, you move up and this way to the left. There we go. Okay? And so it doesn't matter if this is written in negative 2/3, then here I'm moving down 2 and 3 to the right. But this is the same as this. It doesn't matter if the negative's on bottom. I'm moving 2 up and 3 back. All right? So it doesn't matter if the positive's on top or if the negative's on top or the negative's on bottom. So in this case, the slope is 3, and I'm going to put it over 1. And the y-intercept is -6. I'm always going to start with the y-intercept, so that's going to be -6. And then my slope is 3 over 1. So up 3 over 1, up 3 over 1. And then connect the dots. And you can use your handy-dandy ID so you get a straight line. And if I do the second one, the slope is -2 over 1, and the y-intercept is 4. So 1, 2, 3, 4. So from the 4, then, I'm going to count down 2 over 1. And this is the point they cross right here. So this is the solution. It's 2, 0. Just go. So for example 2, these are solved already. So the slope here on the first one is -4 over 1, and the y-intercept is -4. So if I look at this one, it's -4. I'm sure he will. So it's -4 over 1. So which way do I count? I count down 4 and over 1. But that's not very useful. So that's why I'm saying it can go the other way also, where you go up 4 and back 1. So I'm going to go up 4 and back 1. And then I'll connect the lines. the second one, the slope is negative 4 over 1, and the y-intercept is 6. So I'm going to count up 6. And I'm going to go down 4. What's going to happen with these two lines? Why? Because they're parallel, they don't cross, so this is no solution. So in example 3, the y's aren't solved for, so we have to solve for the y's. So I want to solve for the y. So what am I going to do? Add the 2x. And then divide by negative 1. So I'm going to go ahead and graph this. So I'm going to start at negative 1. So I have negative 2, positive 1, negative 2, positive 1. So again, I want to solve for the y. So I'm going to subtract 3. And divide by 3. Does anybody notice anything? It's the same. So that means it's the same line, like one on top of another. So this is infinite solution. Why are you all yawning? We're having fun. What? Oh, good. I was afraid you might be bored or something. Nobody's bored. We're having fun. All right. So this next example, y equals 4. So here's y equals 4. Y equals goes through the y-axis. So x equals negative 1 is going to go through the x-axis. And they cross right here. Okay, the last one. Everybody solve for y and start graphing. So the first one, I'm going to solve for y, so I'm going to subtract the 2x. And divide by 3. So when I graph, I'm going to start at negative 4. Then I'm going to go down 2 and over 3. But I can also go up 2 and back 3. So this gives me my line. And for the other one, I'm going to subtract the 5x. I'm going to start at 3. So they cross right here, and that's at -3, -2.